Alright, this is a video on the solutions for the probability quiz that we did in class today. This is a video solutions guide so that you can go ahead and mark your own answers rather than me having to do it, and that means you can also go back and keep rewatching my answer in case you don't understand just based on my solutions. This is just a modified version of a provided test for the teacher resources from Cambridge Maths. Anyway. So, looking at these first few questions, they are multiple choice questions. So we'll work on these ones first of all. So we have a letter is chosen from the word intersection. The probability that the letter of N is, well, obviously what we want to do is first of all count how many letters there are, which is 12. So count up all the letters, it's 12. And then we want to ask ourselves, well, how many N's are there? There's 2 N's. So this can be 2 over 12, but you notice that none of them are any options. But 2 over 12, if we were to simplify it, it becomes 1 over 6. Next, we have the probability that the letter is an N or a T. This means we need to count up all the N's and all the T's. So we've got 1, 2, 3, and 4. So we're counting 4 over 12. Again, 4 over 12 isn't there, but of course 4 over 12 we could simplify to be 1 over 3. Moving down to the next questions. So we have questions 3 and 4 refer to the following information. So we have those number of heads and the frequency is the amount of times that we've got 0 heads, 1 head, 2 heads, and 3 heads when we flipped 3 coins. So first of all, we want to find the experimental probability of 2 heads. So what that means is, rather than find the theoretical probability, what could happen, we're saying we did this 100 times, what did happen? So we flipped it 100 times, and what's the probability of getting 2 heads? Well, as you see, it can happen 29 times, so it's 29 over 100. And then we also want to see what's the experimental probability of obtaining at most 2 heads. So when we're saying at most 2 heads, that means it can either be, it could be 2 heads, or it could be 1 head, or it could be 0 heads. At most, meaning it can't be any bigger than that. So basically everything that isn't 3 heads. So what we could do is we could do 15 plus 20 plus 29, which would give us the answer. Or we could realize, well, if it's everything that's not 3, and there was 100 in total, if you do 100 minus 36, which gives us, what's that, 64, and then when we do 64 over 100, that goes down to be 16 over 25. So going on to the next page, now we have the shaded region of which the following Venn diagrams describes elements of B only. So we're just saying, well, which of the Venn diagrams shows us B only? Well, the answer is going to be A, but let's go through and see why the others aren't the case. We're looking at option B. We see that the B circle isn't shaded in at all. In fact, that's going to be A only, because we see that it's shaded in the A circle, but it's not shaded in the B circle at all, and nor is it outside, so it's only in the A's. Looking in this one, we see that the B is shaded and also the both sections. So this is just saying B. Not necessarily B only. That's saying B, but also including the people that are B and A. But the question is asking for B only. Looking at option D, well, we see that neither the A nor the B is circled at all. So that means this is just saying neither. And then looking at this last one, E, well, basically we're seeing that everything is being shaded except the A, so this is essentially saying not A, because that means we could be B only, but we'll also talk about the neither. The question's only asking for elements of B only, so we're only looking at where is the B circle being shaded. Then lastly, we've got this two-way table, and we want to find what the value of X is. So what we can't do is just go ahead and straight away find what the answer is. We're going to have to work our way to it. We can see that 9 plus something in here has to equal 13. Well, that's obviously 4. And now that we have that 4, we know 4 plus whatever x is has to equal 7. So our answer is 3. Alright, moving along, we're now going to go towards the short answer questions. So first of all, we're rolling two four-sided dice with numbers 1 to 4 rolled. So what we're seeing here is we need to fill in our table that will map out all the possible outcomes. So just filling this up very quickly. 1 1, 1 2, 1 3, 1 4, 2 1, 2 2, 2 3, 2 4. As you can see, as I'll continue, what we're seeing is we're saying that we're rolling a 3, then a 3, a 3, then a 4, a 4, then a 1, a 4, then a 2, a 4, then a 3, a 4, then a 4. And remember, like, there's no reason why we can't roll the same thing twice. It's not like once we roll a die, if it lands on a 2, for instance, we kind of get rid of that 2 somehow, like scratching it out or something. We can get a 2 again. So now what we're going to do is we want to find the probability that 4 is rolled at least once. We'll just look at the table really quickly. We see that there's 16 outcomes. So we know that the answer is going to be over 16. And 4 is rolled at least once, meaning that it can also be rolled twice. Okay, when it's saying at least once, it means it can't be less than that. So we have the 4 along the bottom, and then the 4 along the right. So make sure you don't double count the 4, 4. So it's going to be 7 over 16. Next P is the sum is equal to 4. So basically we want to add up all the things where they actually, like we added up the two numbers that equals to 4, which is 1 plus 3, 2 plus 2, and 3 plus 1. There's no other options, so it's going to be 3 over 16. The sum is not equal to 4. Well, yeah, what we could do is add up all the possible things and see how many there are, and then that will be the answer. Or just realize, well, if we just found how many do equal 4, well, that means everything else doesn't equal 4. So if this was 3 over 16, well, 16 minus 3 is 13, so this has to be 13 over 16. And then lastly, the sum is at most 4. Well, if we're saying at most 4 now, that means it could be less than 4. I think we did a question like that a second ago. So now we're talking about also all the things that could add up to 3, all the things that could add up to 2, and there's nothing that can add up to 1. So now counting all those possibilities, that's 6 over 16, which we could then also simplify to be 3 over 8 as well. So that's just 1 mark for each of those questions. You don't need to simplify it because the question's not asking you to simplify it, but it's always a good idea to do so anyway. Going to the next question, we have this Venn diagram. First of all, it's asking us just to say how many elements there are in each of these things. It's not really asking for the probability, but we might as well look at how many there are in total. So it's just going to be 3 plus 2 plus 4 plus 6, which equals 15. We'll just hold on to that for a second. So we're first of all saying, well, how many are not in A? Well, again, we could count the amount of things that are B only, or the things that are neither, or just realize once again, well, we can see that here they've got the 3 people that are in A and the 2 people that are in the both. So it means there's 5 people that are in A. If there's 5 that are in A, that means there's 10 that aren't in A. So the answer is 10. Next, if we're asking neither A nor B, well, that's basically the neither question, so that would be straight up 6 because it can't be in either the A or the B circle, nor as it can be in between. And if we're asking for A and B, well, that is the both part, so that's just 2. We're just looking at the intersection. Going down to these probabilities now. So now these questions, it's talking about the probability. So in the previous question, it's just asking how many there are. Now it's asking what the probabilities are. So here I want to find the probability of A. Well, we just talked about how many people are in A. That's 5 over 15 now because we're choosing out of 15, which we could then simplify to be 1 over 3 if we want to. Again, it doesn't tell us we need to simplify it, so we don't need to. It's always a good thing to do it though. Next, we're looking for A or B. Well, basically that means there could be A only. So it could be these people. It could be B only, so it could be these people, or it could be the people that are in the middle. So if we add them up, 3 plus 2 is 5, plus 4 is 9, we get 9 over 15. Just remember the difference between and or. And is when you're thinking about the both, or is when you're thinking about how many people are in this only, that only, or both. You've got to count that. Here, if we're talking about A only, that means we're looking at the people that are just in the A circle. We're just looking at those three. So that'll be 3 over 15, which equals 1 over 5. And then lastly, here we've got P given, the probability of A given B. So this means we're not choosing out of the whole 15 anymore. We're now choosing out of the people that are in B. So if we need to, first of all, ask ourselves, well, how many people in B? Well, we've got these 2 people and these 4 people. So we're choosing out of 6 people this time, not out of 15. And then now what we're asking is, well, of those 6 people, how many of them are also in A? Well, that means you're looking at the people that are in both. So it's going to be 2. So we've got 2 over 6, which equals 1 over 3. The last question is, well, are these events mutually exclusive? Why or why not? No, they're not mutually exclusive, because as we know, what mutually exclusive means is if you're one thing, you cannot be the other thing. There is no both. And just look in that Venn diagram, there is an overlap. Because there's an overlap, there are people that are both A and B. So that means it is not mutually exclusive. So no, because 2 elements are in A and B. Basically, you just need to somehow explain why. You could say, like, yeah, there's an overlap in there, therefore there's a both. You just need to say it somehow. That's the case. Going to the 5th page. So we're going to the extended response questions. Doesn't really make a difference. So here we're told that we have 20 people in the aquatic team. 15 people like swimming, 8 people like diving, and 3 like neither. Now, obviously, if we like add these up for a second, if we do 15 plus 8 plus 3, that equals 26. So this is kind of saying we had 26 votes, I guess we could call it. Which doesn't add up, because if we had 26 votes, but there was only 20 people, that means some people have been double counted. In fact, we know that 6 people were double counted. Okay? So if we want to say the number of people who like both swimming and diving, we had our 26 minus the 20 people that should have been there, which equals 6. So therefore 6 people like both like swimming and diving. And how many people only like diving? Well, we just said that 8 people like diving, but we just said of those 8 people, 6 of them also like both, like swimming. That means they like both. So if you've got the 8 people that like diving, 6 like both, 8 minus 6 equals 2. We're saying that of the 8 people, only 2 of them only like diving. So now we have this information to now be put into this two-way table. Now when we're doing these two-way table questions, particularly with this ones where we need to track back and say both, find the both because we've got too many votes, when you're doing these two-way tables, it's just good for you to write 20 down at the bottom right straight away. We know that has to be 20 because that's how many people were in the team in the first place. So if your numbers don't add up to 20, you know you've made a mistake. So from that, we can now fill out the rest of the numbers. We were told, well, we figured out that these 6 people like both, right? So that means they do like swimming and they do like diving. So that means they're going to be in the swimming column and the diving column. So that's 6 people there. We were also told that in the question, 15 people like swimming. So that means there's 15 people in total that like swimming. We're also told that 8 people like diving. So 8 people like diving in total. And we're also told that 3 like neither. That means they don't like swimming, they don't like diving. So we're going to put that number there. And going from there, we can now fill in the blanks. We know, looking at that right column total, that total column, we have 8 plus something equals 20, so that's got to be 12. 15 plus something equals 5. Just fill in the blanks. So 2 plus 3 equals 5, so we can put 2 there, and as we know, 6 plus 2 obviously equals 8, and then this will be 9. So from that, now that we have each of these numbers, we can now go ahead and do some more probabilities. So a person from the aquatic team is chosen at random. This means we're choosing out of 20, okay? Find the probability that a person likes both swimming and diving. Well, that means they like both. So it's just going to be straight up 6 over 20, which simplifies to be 3 over 10. Next is they only like diving. That means they do like diving, but they don't like swimming. We just said that a second ago when we'll ask only diving. We'll ask how many people there are. That's these. So we're doing 2 over 20, 2 over 20, which equals 1 over 10. Like swimming given they like diving. So this is one of these questions again where this time we're not choosing out of the total 20, we're actually choosing out of the people that like diving. So we need to ask ourselves, well, how many people like diving? Either looking at our table that we made up here. So we're looking at these 8 people, or we could have just read the question, it says 8 people like diving. So we know we're choosing out of 8. And now the question is asking, well, of those 8 people, how many of them also like swimming? Well, we see that we're looking at this row, but also like swimming. So we've got 6. So this will be 6 over 8, which equals 3 over 4. And lastly, they like diving given that they like swimming. So it's the opposite. This time we're choosing out of 15, looking at the top, and they also like diving. So again, this will be 6, and 6 over 15 simplifies to be 2 over 5. That's our answer for that one. Go to the last page. So this is talking about a 2-step experiment without replacement, meaning that the probabilities will change. So first of all, we want to draw a tree diagram for this. Remember, whenever you're drawing a tree diagram, you always start at a single point. That's where lots of people get confused straight away. When you start drawing a tree diagram without starting at a single point, you will get confused very quickly. It seems weird, but trust me, it helps. Then, go from there, we first of all need to be thinking about first choice. So, we can either choose a red or a white. So, red or white. Then, after that choice, we're picking another marble. And again, that means we can choose red or white. Red or white. So there's our 2 levels. Basically, this is our first choice, and that's our second choice. Bring that up a little bit more. That's our second choice. You can see that every branch level kind of tells you the different stage. And also our sample space would be RR, RW, WR, and WW. Now, what we also need to do is the question's not asking just showing all the outcomes, we also want the probabilities. What we need to do is find the probabilities of each of these branches. So in this first choice, we were told that there were 3 reds and 2 whites. So that means there's 5 in total. Okay? So that means the probability of choosing red would be 3 over 5, and the probability of choosing white would be 2 over 5. Going from there, we now need to think about, well, what happens in the first stage, because that will affect the second stage. More on that later. So, first of all, if we chose a red one first, going up this top branch, that means there's 1 ball less. So this will first be out of 4. If we chose a red ball, if we initially had 3, if we took one of the red balls away, we now only have 2 left over. And then for the white balls, well, still there's 4 balls left over, but we didn't take any of those 2 white balls at the start, so there's still left over 2. Going the other way, again, if I took a white ball first, there's 4 left over, but we didn't take any of the red balls, so we still got 3 red balls left, And if I did take one of the 2 whiteboards left, I got 4 left over. So now we have the probabilities of each of these individual events. And now what we can do is find the probability of each of the total outcomes. And remember, that's what we do is we multiply down the tree. So doing R first of all, we'll do 3 times 5, 3 over 5 times 2 over 4. What you do is just multiply the numerators, multiply the denominators. So we get equals 6 over 20. Going down this branch, we can get 3 over 5 times 2 over 4, which is also 6 over 20. This is also 6 over 20. This is 2 over 20. So now we have, I'll just move this to the side. So now we have all our outcomes, red, 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 white, white, red, white, white, and each of their probabilities. So now we want to find the probability of selecting the following. So a white marble followed by a red marble. So this is just WR, which we already know is 6 over 20. That's what we wrote over there a second ago. 2 red marbles, well that's just RR. So that's RR, which is 6 over 20. Exactly 1 red marble. So this is what we're saying here is you can either choose the red marble first and then get a white marble, or choose the white and then the red. So it can be either this one or this one. So it's going to be 6 over 20 plus 6 over 20, which gives me, so we can say red white or white red, which equals 12 over 20, because we add those 2 probabilities. These 2 here, we'll add them. And then lastly, what are the events dependent or independent? Well, I've already said it a few times, or at least I've inferred to it, but these are dependent. And the reason why they're dependent is because whatever happens in the first stage will affect what happens in the second stage. Here we saw if I choose a red marble first, then this will be 2 over 4 and that's 2 over 4. But if I chose a white marble first, well then this is 3 over 4 and that's 1 over 4. See how the probabilities change? That means they are dependent, right? The events are dependent on each other. So dependent because the probabilities change. Probabilities change depending on the first choice. Basically what we're saying here is whatever happens in the first stage will affect what happens in the second stage. Anyway, this has been a longer video, but hopefully it has been useful. Make sure you keep going back to questions you don't understand. Don't just read through it, wait for it, and wait for the answer to come up. It's very useful for you to rewatch it and even just ask me questions if you need further clarification. Anyway, hopefully it's been helpful, and see you later.